So may I start? Hello.
Yes.
Okay. So lecture 12 we have some integration, and that is like, firstly we have the solution of previous homework. Maybe I have also talked about this homework before, but I'm going to discuss it again. So we have some kind of, we have two property, right? Number one, that is for odd function, and number two, that is for even function. Okay, so you see here our question is integration of -1 to 1 2x square plus x cos x by 1 plus root over 1 minus x square dx. So this is a symmetric interval, right? Symmetric interval means, you see here our number is same, just the sign is different, right? One is +1 and another one is -1. So this kind of interval, they are called symmetric interval. Okay, so for symmetry, if there is any symmetric interval, then we can consider about the odd function and even function formula. Okay, so for example, we have plus here, right? So our main target is we have to break down this function into something like some formula that we already know. For example, the last line here is integration of 0 to 1 minus root over, oh no, sorry, not this line. The number 1 x square by 1 plus square. So the last line is here. Yeah, maybe here. Yes, pi by 4. So we have to convert it like some kind of formula that we already know how to calculate. Okay, so to do that, firstly, here we can just divide this whole function. From this plus sign we can divide this whole function. So you see here I am dividing from here. So one part is here, and another part is here. Let me drink some water. So one part is here and another part is here. So let's look at firstly let's look at here. So if we want to use some kind of odd function and even function formula, then we have to find f of minus x. Okay, we have to find f of minus x, and we have to see if it is equal to minus f of x or not. So that's why I just write minus x instead of plus x. You see here also, here I just write minus x instead of plus x. Actually I talk the whole day because I have 2 tuition and just tuition after tuition. That's why my voice condition is not so good. I cannot talk. So you see here f of minus x, right? F of minus x. So now we are considering this. Part. Integration of -1 to. We are considering this part. So we are finding f of minus x. So if I just if I just plug in the value here, minus x, and also here, so the thing will be, you see here, minus x squared, that means plus x squared, and here also minus x squared, that means plus x squared. So we will find that they are same, right? f of minus x is equal to f of x. Guys, see here, f of x, f of minus x is equal to f of x. That means it is a even function. That means it's a even function. So now we will use this formula, like if it is a even function, then integration of minus a to a f of x dx, it will be 2 integration of 0 to a f of x dx. Okay, this is the formula of even function. So now you can just calculate the next part, this part. Okay, so for even function, okay, 2x square. So this part is calculated here. Okay, here. So after this line, after this is not a line. Okay, I just written here the formula. So the next line is here. So now you see we use this formula. Okay, we use this formula. So integration of minus 1 to on 2x square by on plus root over on minus x square dx. So now from the formula we know that it will be 2 into integration of 0 to a f of x dx. So here is 2 into integration of 0 to 1, then f of x, right? So this is f of x and dx. So ultimately the answer will be, you can also just take this 2 out, right? So 2 multiply 2, that is 4, and we have integration of 0 to 1 x square by 1 plus root over 1 minus x square dx. So now we have to calculate this part. Okay, so this part here, we are calculating this part here. So you see we have some kind of x square, we have some kind of two function. One is here, not two function, we have some, we can divide, we can just consider this plus sign, and we can divide this x square with on, but we should not divide because this is not the formula. Like we can divide this thing, a plus b by 2. We can divide it like a by 2 plus b by 2. But if it is something like 2 by a plus b, so we cannot divide it like 2 by a and 2 by b. Okay, 2 by a plus 2 by b. So we cannot do this do this way. Okay, but we can do this way. So that's why we have that's why I am not breaking this this function. So I will just multiply using the conjugate. Okay, so conjugate means the opposite sign of denominator. I mean the opposite side of the denominator means here we have plus, right? So we will multiply using minus. For example here, so you see here we had plus, so we are multiplying using minus. So from also upside and downside. Okay, so what is the benefit? The benefit is this down part, it will make something like a plus b into a minus b. That means a square minus b square. Okay, and then we can cancel out root and a square, right? So we get on minus on, plus x square on minus x square. So and upside we have x square into on minus root over on minus x square, this line. Okay guys, and now maybe you can also cancel out x square and on minus. Okay, so if I just do another line here, it will be on minus 1 plus x squared. So I can just cancel out this 1 plus 1 and minus 1, and also I can this was x squared. So also I can cancel out this this x squared and this x squared. Okay, so ultimately we have only this function. Okay, so you see here, after a long process from from here to here to the second page here. Okay, so after a long process we only get single line equation. So maybe now we can just calculate the function. So it is so let's go back here. So we had 4 into integration of 0 to 1 x square by 1 plus root over 1 minus x square. So we just calculated this part, x square by 1 plus root over 1 minus x square. So this line here we are doing after this line. Okay, after this line. So we are doing after this line. So this is our 4 root over into root over 0 to 4 integration of 0 to 1 minus root over 1 minus x square dx. And now I can divide the integration sign. I can just divide the I can divide the integration sign here and also here. So they will make integration. So again the network issue. So you see here, I can just divide the integration sign with on and root over on minus x square. So this part we calculate it here. We calculate it here. Where is that? Okay, I can calculate maybe I can calculate here. So integration of 0 to 1 on dx. So it will be integration of on. Integration of on is x, and then from 0 to 1. So you can see, right, we have to plug in the upper limit and lower limit. So this is on minus 0, that means 1, right? So this 1 is here, and we have 4 here, right? So 4 into 1, that means 4, minus integration of 0 to 1 root over 1 minus x squared dx. So guys, we don't know how to calculate root over 1 minus x squared dx, right? Because there is no direct formula. That's why we have to use substitution rule. Okay, or we can do another thing, like we can use the use the geometric meaning. So if I can convert this function into something like a geometric figure, then I can find out the value. So for example, our Laushi firstly showed us the first way, the geometric meaning way. So this is our function, and we call it y. Okay, so y is equal to root over 1 minus x square. And now we have to now we have to square. We have to square on the both side. So this square and root get cancelled. So we get 1 minus x square. And if I just take this x square on the left side, so we get x square plus y square is equal to 1. So this is the equation for a circle, okay? X square plus y square is equal to a square. So here a is our 1, okay? So 1 square is also 1. So this part here, this is equation of circle, okay? Because we know the equation of circle is x square plus y square is equal to a square, okay? So here a is our radius. A is our radius. So okay, fine. Now if you look at the limit, that is 0 to 1, integration of 0 to 1. So this is our 0 point, and this is our on point, right? And then if you see here, we have so firstly we have to calculate the integration value of this function, and then we can calculate how it looks. Oh, sorry. So as we are using geometric meaning, that's why you can see our radius is 1, right? From the equation we can see our radius is 1. So we know that area of a circle, that is pi r square, okay? Area of a circle, that is pi r square. So this is our pi r square, okay? So here our radius r is 1. And why we have 1 by 4? Because if you look at the figure, so this integration from 0 to 1, that means from this part to this part, the circle will only cover 1/4, right? Only this part. That means it will only from integration of 0 to 1, the circle will cover 1/4, okay? Only 1/4. So that's why I multiply 1 by 4 here, okay? 1 by 4 here. So ultimately, if I calculate, that will be pi by 4. So this is way 1. And the second way is use substitution, okay? Only the second way is substitution rule. So for example, we can just this is a Trig substitution rule, okay? So Trig substitution rule is root over a minus bx square. Root over, if we have a function something like root over a minus bx square, so then we can use Trig substitution rule, okay? So let me show you some formula for Trig substitution rule of integration. I wrote it somewhere, maybe. I don't remember. So there was three formula for Trig substitution rule for integration. So let me write down here. So maybe the first one is if we have some function like root over a minus bx squared. So here a is any constant and b is any constant. Okay. So we have 1 minus x squared. So here a is equal 1 and b is equal also 1, right? Because the coefficient of x squared, that is 1. So the substitution, I mean trig substitution formula, it will be root over a divided by root over a. So x will be equal to root over a by root over b sine u. Okay, sine u. Let me show you the formula in another place. That is here. One, two, three, and four. Guys, can you see? Farin?
Yes.
Okay.
Yes, I can see.
So this is the trig substitution rule. So if we have a function something like root over a minus bx squared, so here substitute x will be root over a by root over b sine u. And you can see here the coefficient of in this case our a is on and b is also on, right? So here a is on, b is on, so root over on by root over on, that is 1. So our x will be sine u. Okay, from the trig substitution, from the trigonometric substitution rule, our x will be sine u. So now the dx by du will be, now if we differentiate on the both side here, okay, if we differentiate on the both side here, maybe I need to make PDF, just a second. So now I can edit. So x is sine u from trigonometric substitution, or x will be sine u. Okay, from the formula. So if I differentiate on the both side here, dx and d sine u, so they will be, so if I differentiate on the both side now, so they will be d dx of cos u, d du of x, that means d dx, no, d du of x, that means dx du, it will be cos u. Okay, let me clarify it. Dx equal to d sine u. So d sine u means sine u derivative, du, right? So sine u derivative is cos u. So cos u into du. So now if I just take this du on another side, so it will be dx by du. Okay. So dx by du is equal to cos u. Mitchell, am I right? Hello.
Yeah.
Okay.
Yes.
So ddu of x equal to cos u. And now, so now we have to substitute u here, okay? Because dx, we know dx will be dx by du will be cos u. So we know that dx will be cos u du, okay? Dx will be cos u du. This line. Dx will be cos u du. So we just substitute the value here. So dx will be, you see here, dx will be cos u du, okay? And we already laid that x will be sine u, right? X will be sine u. So I also substitute x equal to sine u here. So sine u, and we have a square here. That means sine is square u. Okay, sine is square u. So ultimately integration of root over 1 minus sine square u into cos u du. Um, can you understand how this line came? Hello.
Yes.
Okay.
Yes. I can understand
Okay,
a
Farid.
bit.
Yeah. I also understand that my teaching skill has decreased so much because, first of all, uh, my voice, my health condition is not good for these 3 days, because like I have been teaching from,
No, it's not your fault. Actually, it's not your fault. Something fault. I mean,
even sometimes I cannot talk
everything
because
is my fault. My head is not going through.
yeah, I can't rest even for 10 minutes the whole day. That's the main problem.
It's okay. You're already doing
I
your
need to go
best.
for tuition at like 6 6:50 a.m. Okay, because I have to go there, no, maybe 7 a.m. And then from 7 a.m. to something like 9:30, or somewhere around 10 a.m. I stay my grandparents' house because I have some students. They are in grade 10, and then I take my breakfast and I come back to my home, from my grandparents' home to my home, and then at around around on PM or around on 30 PM. I again go back there because I go there for shower, okay, just for shower, and then again I take my supper. That means lunch. I take my lunch there, and I came back again to my home, and again at 3 p.m. I go for tuition, and around 6 p.m. I come back to my home. So you see here, always I am just running and running. So from I think maybe from 11 a.m. to somewhere around on on PM. I have time to study for myself, and the rest of the time I spend for others. So that's the big problem of my current situation, and I need to change this as soon as possible because yeah. So let's not discuss about those. How to remove this over. And you see my internet connection, it is coming and going, so it is making me more frustrated, like I have to change my SIM card because yeah. So guys, we have come up to here, up to this line, and Mitchell can understand but Farin cannot understand. So Farin, the thing is here, let me start from the beginning. So we have integration of 0 to 1 root over 1 minus x square dx. So we don't know, we don't have any formula for this, okay? Because you see here, we have some kind of x square here. We have some kind of root function here. So that's why we need to use substitution rule. So, but in this case, it's more likely easier to use trig substitution rule, okay? So trig substitution rule is here. If we have a function something like root over a minus bx squared, so here a and b, they are constant. So the x will be root over a by root over b sine u, okay? And now we can just plug in the value here. Like we have a a is 1 and b means the coefficient of x squared. So coefficient of x squared, that is also 1. So root over 1 by root over 1 sine u, that means only sine u, okay? So here our x is sine u. And now we have to find what is dy, okay? What is the derivative value of, so we have to differentiate both sides, dx and d sine u. And from we already discussed a small formula, that is uh, dy is equal to y derivative dx, okay? So from this formula we have to find this is our y, okay? So derivative of sine u, that will be cos u. The derivative of sine u, that will be cos u. And then we write what? Dx. That means du. We write du. Okay. So cos u du. And if so, this is dx value. So instead of dx here, guys, this was our main function, right? So instead of dx here, we write down cos u du. Okay. So this is cos u du. And instead of we are substituting what? We are substituting instead of sine square. Okay. We are substituting x, okay? So instead of x, we can write down, guys, see here, x equal to sine u, right? X equal to sine u. So we can write sine u here. But here is x square, right? Not x, here is x square. So sin u square means sin u square. Okay, x square means sin u square. That means sin square u. And let's go to the next line. Farid, can you understand this line now? Maybe I have to discuss in Bangla. I have to take Bangla group study, right? For this part. And the next line we have 1 minus sin square u. So 1 minus sin square u, that means cos square u. Okay, cos square u. And we have root over here, so we can cancel root and square. So ultimately we get cos u. Okay, here for this value we get cos u. Guys, we have only on minute left, so we will join again. Okay, so we get cos u. So cos u into cos u, that means cos square u. Okay, cos square u. So that means finally we have integration of cos square u du. And the next line we have to yeah. But now as we use substitution rule here, that means we have to change the limit. Okay, we have to change the limit or the boundary. So here our limit was 0 to 1, right?